So I'm going to flip to the next slide here, and I want to look at the naming of how we name the longest chain. And you can see we have a whole bunch of prefixes right here. And you'll see they go in order. Now if we have a prefix of meth, what that implies is we have one carbon. If we have a prefix of F, that means we have two carbons. If we have prop, we have an example of 3, and so on. So this is how we're going to name the first part of our carbon chain. We haven't talked about how we're going to name the second part of our carbon chain. So we want to flip back to the previous page for a moment. I want to take a look at the functional groups. Now, the ending of it has to identify the bond types. Now, if you remember when we're talking about covalent bonds, we know that there can be examples of single, double, or triple bonds. And we need to have a way to name that. Now, there will be other examples later on in the unit, but I don't want to get ahead of ourselves. I want to focus simply on our lesson for today. So, when we have an ending of ane, what this implies is that all of our bonds are going to be single bonds. So what I want you to do is I want you to pause the video right now, and I want you to see if you can figure out on your own what pentane is going to look like. Okay, I'll assume at this point that you've been able to try pentane, and you'll see that the answer is we can see it's a molecule that's just appeared in front of us. Now the formula here, if we can count that there are 5 hydrogens, so it's C5, and we can count that there are 12 hydrogens, H12. We know that because the ending was in ane, that all of these had to be single bonds. So there's our pentane. Yet again, this is a lot of work. So we're going to try writing the condensed formula, which looks like that. That would be our example of the condensed version. If we want to draw out our line version, it's very simple. It's going to look like that. Now naming is going to get a little bit more complicated than this, so I want to instead talk about what we have here, the alkyl groups. These are basically carbon subgroups off of our main chain. So for example, if I wanted to have 2-methyl butane, how would I draw that out? Well, butane, we know, is going to be 4 carbons. Ane implies that it's all single bonds, so we know we've done it correctly here. Now this part where it says 2-methyl, what this means is that at the second carbon, we are going to have to draw a methyl group. And what is a methyl group? It's CH3. Now if we were to draw this example as a condensed version, that would look like to me CH3, CH, CH2, CH3, and then CH3. Now when you're numbering them, what the numbering is going to be is that you're always going to number it in the order that gives us the lowest number, or the largest carbon chain. Now the last thing I want to say before we move on, if we're going to go back to the original slide, is at the beginning what we just described there, that was an example of a substituent. What we're going to talk about today, and there are many examples of this, but we're going to simply focus on alkyl groups. We're going to focus on the alkyl groups that are attached. Now, what's important with these is that we list the number position. Now, what if you have multiple chains with multiple names? What's important when you're doing this is that it goes in alphabetical order.